Now, if anybody wants anything cleared up, I'm just going to throw this out here. There are two lineages here, placentals and egg layers. We know this. The divergence, I believe, between the protocetacean, because as you have a mammal-like reptile, which is a monotreme, you have reptile-like mammals, which are the cetacean. In this aspect, a protocetacean, which is the ichthyosaur, ichthyoseti essentially, diverged from a lobe-finned fish. This is one reason we're related to frogs, caecilians, salamanders, reptiles, and all this, because we diverged at least 300 million years ago. Now you have amphibians, snake-like ones. They're going to evolve into snakes. Look at the caecilian's jaw. The tetrapod ones are going to evolve into lizards. Now these guys are probably still going to evolve into lizards, but large lizards, like monitored lizards, because in early Earth there were large snakes, large frogs, and large salamanders. And all of these in this family lay eggs. So it diverges from a fish to an anapsid, which are all the amphibians. They evolve into diapsids, but they all still lay eggs. Then ultimately, a warm-blooded egg layer, a mammal-like reptile, the synapsid monotreme, comes along. Now platypi give birth to 1 to 3 eggs. The echidna, on the other hand, is like us. It came to the land, so it only propagates 1 child. They only lay 1 egg at a time, like we have typically 1 child at a time. This was the first question that helped me get on the series of questions of asking the right questions. What animals give birth to 1 offspring? And it's only the larger mammals, and we happen to be one of those. We are in fact the next to the largest one, just over essentially monkeys, like technically the mandrill or a howler monkey. So when it diverged, the protocetaceans come along. That's the Seta artiodactyl 100 million years ago. Through 70 to 66 million years ago, you have Ambulocetus around 55 million years ago, Archaeoceti, and artiodactyls, which are Archaeoceti, Basilosaurus, Durodon. All of this is between at least 70 million years ago to 20 million years ago. And ultimately, by the time the second radiation hit, echolocation will evolve. This is a large cerebrum. So like all these animals here, the Archaeoceti had small brains, but were coming out of the water from a small brain progenitor. Once this guy ultimately evolved into the larger guys, because the larger animals mutate slower, they evolve at a slower rate. Just like the flies. The flies grew the extra antennae because they're smaller and they go through more generations. Just like us giving birth to 1 offspring, and we live, around 100 years. So our mutational rate is a lot slower. But as they pass dwarf genes, the mutation rate's going to get higher and higher, just like I was explaining with the birds. And that's why there are so many variations of birds. And this is one reason that the birds share so much DNA, or they're so close cousin to a frog technically, because these guys are hind propelling animals. Their locomotion is hind locomotion, jump. This is a primitive form of running, essentially. So the legs are going to evolve. Now they found bipedal frogs, and I'm willing to bet that since the theropod evolved from a hind locomotion amphibian, and since the birds are so closely related to frogs with the DNA and proteins, that they become the theropods, salamander, like I said, tetrapods, and then you have limbless. And now snakes are at a point, or re-evolution, now this is just a theory, that they're going to start growing limbs. But ultimately there are snakes that grow limbs, just like we're going to grow limbs. The cetaceans in the water are going to come to the land. Just like now, between the 20 million years ago, 30 and 20 million years ago, we came to the land from a cetacean form. Yes, we evolved from fish, but we diverged in the water. We come out of the water as a live bearer. We don't go from a placental animal all of a sudden to laying eggs, or from laying eggs all of a sudden to a placental. And the marsupial, I know everybody wants to go to the marsupial. It still forms a placenta for a very short time, but ultimately a placenta does form in a marsupial. They are in a completely different family. And I'm just saying, marsupials and monotremes, the mammals most distantly related to the placental mammals, share essentially the same genome, but show major variations in chromosome organization and function. So this means this is epigenetic. Both of these are going through an epigenetic change. The kangaroo is going to develop hips, or at least the marsupials are going to try to give birth to fully functioning live babies, and not just a placenta or zygote. Whereas these guys still lay eggs, but they grow a mammary gland. And that's an epigenetic structure. We're not phylogenetically related at all. The only reason we're even related is because we share a lot of DNA with an ancient ancestor. And this is one reason we share so much genome with the coelacanth over many other mammals, is because the coelacanth, the ancient fish that diverged into these guys, the lobe-finned fish that diverged these lineages, is closer related to the coelacanth from hundreds of millions of years ago. Coelacanths are actually more closely related to humans than other mammals, even than to ray fin fishes. But ray fin fishes didn't come until about 200 million years after the lobe fin fishes. So he's going to be closer related to the older fishes. The Basilosaurus is a misleading name, just like Ichthyosaur is a misleading name. I'm just going to throw this out here. All is well. Well, water. See, essentially they're only a diapsid because we skipped that anapsid stage. And that's why they confuse this with a reptile, but it's not a reptile. It has all the traits of a mammal, but it has a reptilian-like skull because it's a proto-synapsid. It's a baby synapsid. It's still got a diapsid-like skull before it evolves into a synapsid, which is a large brain whale. And when this echolocation evolved through that radiation, the limbic system of the whale is so large that it actually erupts into the cortex in the form of an extra paralimbic lobe. That's when it evolved. That's why all these guys got smaller brains than modern whales. The brain is always the last thing to evolve. Always. No matter what it is, what animal it is, the brain's always the last thing to evolve. And the stomach, its digestion, and its procreation are always the first things. So when it comes down to it, a phylogenetic mutation comes from the father. That's when a mutated sperm is passed that is a slight modification. And as they evolve parallel on the planet with each other, they're sharing a lot of epigenome because the Earth itself and the ecosystems are telling their genes how to work. So over this time, they're going to start sharing a lot of DNA. But ultimately, they don't share the phylogenetic DNA. They're not genetically related to them, except for through an ancient relative. And that's why, since they're so far related, the mammals most distant related are marsupials and monotremes. This is why they're most distant related, because we are at the end here, and they are at the end up here, and we're related to the kangaroo through the marsupial through the kangaroo. See, the environment is telling this monotreme, hey, you're going to have to develop you a little mammary gland, and it's like, oh, and its DNA develops a mammary gland. Like us, because we're evolving along with each other, and Earth is telling us this stuff. That's our epigenome. What it's telling the kangaroo is, you need to start giving birth to live babies. And they give birth to one joey. We give birth to one offspring. Koalas give birth, basically a joey too. And like us, an epigenetic change is going to tell the echidnas, since they're on the land and they're so distantly related to us and we're on the land, to have just one offspring. Like it tells our epigenome. Like the fish and the ichthyosaur. Phylogenetically, they resemble each other, but epigenetically, since it lives in the same environment, it has a lot of the same structures. But the environment also tells it to start giving live birth and have blubber and silky skin or smooth skin, soft unlike scaly. And they inherit a large cerebellum from fish. And up here, essentially, these monotremes are endothermic. That means they can produce their own heat, like the birds. But the birds are still in this family here. It's working its way to being warm-blooded. The heart evolution even consistently goes in a linear fashion. It goes from 2 to 3 to 4. Crocs with cold-blooded 4-chambered heart, and monotremes with 4-chambered heart warm-blooded. Whereas we already had a 4-chambered heart when we came out of the water, and we've always had one. But through this line right here, I believe, now this is just a theory, I don't know if we'll ever know for sure, we might find a heart of an ichthyosaur, but I'm willing to bet right now, theorize, that they have a septated heart similar to a turtle's. They have a 3-chambered heart that's septated, evolving into a 4-chambered heart. And by the time it reaches a 4-chambered heart, which it needs for a larger brain, because of the echolocation and the secondary radiation, the cerebrum evolving, that's when it fully septated and became a 4-chambered heart. Now it's just a theory, but it makes sense. Unlike the birds, which are warm-blooded, have a 4-chambered heart, but they have a little brain. It's just simple variations. But we look at it with black or white and never in between. Like mammal-like reptile, reptile-like mammal. Variations of warm and cold-blooded. Large brains, small brains. Everything developing in a linear, proper fashion, organized in a very orderly fashion. Because I believe Mother Nature is not stupid. It doesn't work with random, garbled nonsense. It works in a very particular manner. And nobody wants to give it that credit. Well, a lot of people do. They want to talk about intelligent design, but then a lot of people want to start with other stuff after that, which is cool. That's fine. It all happens. It works. It doesn't matter if it was created or it exists, whatever. Creation is existence or formation, whatever. It had to come from somewhere. Even if it was nothing, it came from somewhere. It exists now, and that's all that matters. And it came to be. It didn't come to not be, like a gainer. Which is basically scientists